Good day everyone! For today's video, we're going to discuss about the sigma notation or summation notation. Now let us define it. Sigma notation or summation notation is a shorthand for writing sums or computing the sums of numbers and algebraic expression. Now, we all know that this sigma notation, it is our uppercase Greek letter. Means to say, it denotes sum. Okay? Now, how are we going to read this sigma notation that we have right now? So, we read it as the summation of f of I from I equals m to n. Or the sum of f of I from I equals m to n. Or it can be read also as the sum of f of I between m to n. Okay? Now, we have several parts of this sigma notation. So, let us discuss it one by one. So, I stands for our index. And then we have m, we call it the lower limit or the lower bound. Or we call it also as our starting point. And then we have n, or the upper limit, or the upper bound. And then we have the f of I. This is the term or summand of the summation. Okay? So it means to say that we have the lower limit and the upper limit. So you're going to get the sum from starting point or the lower limit up to the upper limit. Okay? Now for us to understand about this sigma notation, let us use our concept now in evaluating the sigma notation. So let's start with this one. Example number 1. So we have to expand the summation and simplify if possible. So we have example number 1. So the summation of 2x as x equals 1 to 3. So what you're going to do is to substitute the index, or we have x there by 1 up to we reach the upper limit, and that is 3. Okay? So, equals, we have 2 times 1 plus 2 times 2 plus 2 times 3. Okay? And then, we solve it now. 2 times 1, we have 2. Plus 2 times 2, 4, plus 2 times 3 is 6. And then get the sum. We have 2 plus 4 plus 6 is equal to 12. Now, the summation of 2x as x from x equals 1 to 3, and that is equal to 12. Okay? Next. Let's proceed to example number 2. By the way, I want you to observe the series that we have right now. For example number 1, we have 2 plus 4 plus 6. Observe it. So as you can see, it is an example of arithmetic series because they have a common difference, and that is 2. Okay? Then next, example number 2. We have the summation of the quantity of 2k plus 3 from k equals 2 to 4. So same process. So you're going to substitute k. We'll start with 2. So we have 2 times 2 plus 3. Then plus 2 times 3, this time we're going to use 3, plus 3, plus until 4. So 2 times 4 plus 3. Okay? And then solve. Now, in every parenthesis that we have, so 2 times 2, we have 4. plus 3. Okay? Plus 2 times 3, 6 plus 3. Plus 2 times 4 is 8 plus 3. And then 4 plus 3, 7. Plus 6 plus 3, we have 9. Plus 8 plus 3, we have 11. And then get the sum, 7 plus 9 plus 11, and that is 27. Now, the summation of the quantity of 2k plus 3 from k equals 2 to 4, and that is 27. Okay, so if you're going to identify, observe this series that we have 7 plus 9 plus 11, it is also an arithmetic series because we have the common difference, and that is 2. Okay, now let's proceed to example number 3. So for example number 3, we have the summation of negative 1 raised to L plus 1 times L from L equals 1 to 3. So same process. Okay, so we're going to wait. Okay, ayan. So we're going to substitute L from 1 up to 3. Okay, so we have negative 1. So that is 1 plus 1 times 1. Okay, so use bracket. Plus negative 1 times, this time 2, plus 1 times 2. Okay, plus we have negative 1 raised to 3 plus 1 times 3. Okay, and then simplify every parenthesis that we have. So negative 1 raised to 1 plus 1, and that is negative 1 raised to 1 plus 1. 1 plus 1 is 2. So we all know that every time if we have the exponent and that is in even, automatically whatever the sign of our base is still positive. Okay, so negative 1 raised to 2 is 1. Okay, times 1. Plus negative 1 raised to 2 plus 1. 2 plus 1 is 3. Means to say that is odd. So if our base having a negative sign, if its exponent is odd, then still negative. Okay? The sign of our base still negative. So we have negative 1 raised to 2 plus 1, and that is negative 1 times 2 plus negative 1 raised to 3 plus 1. So that is 3 plus 1 is 4. So our exponent is 4. So negative 1 raised to 4. And that is even. So we have 1 times 3. And then 1 times 1, we have 1 plus, we have negative 1 times 2. So that is negative 2. Plus 1 times 3 is 3. And then get the sum, 1 plus negative 2 plus 3, and that is negative, that is 2. Okay? Now, the summation of negative 1 raised to L plus 1 times L from L equals 1 to 3, and that is equal to 2. Okay? So, now, let's proceed to, this time, we're going to reverse it. So, a while ago, we have the sigma notation, we evaluating it, and get the sum of that sequence. Now, we're going to reverse it. So, we have an expression, and then we're going to write it in sigma notation. Okay, so how are we going to do that? Okay? Ganito lang. Oh. Okay, sorry. Nagalaw? Ayan. Okay, so we're going to write the sigma notation from this expression that we have right now. So before that, you need to identify the series that we have. If it is a arithmetic series or a geometric series. So try to identify it first. Since we have here 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23. And then this one is an example of arithmetic series. Okay? Simply because they have a common difference, and that is 3. And let us check if that is arithmetic series. So by subtracting our second term and also the first term, let's say we have 8 minus 5, and that is 3. 11 minus 8 is 3. 14 minus 11 is 3. 17 minus 14 is 3. 20 minus 17 is 3. And 23 times 20, minus 20 is 3. Okay? Now, kung yan ay may common difference na 3, so to write that in sigma notation, so you need to write the sigma notation there. And then we have a common difference, and that is 3. Always, if that is a arithmetic, so get the common difference. Write it down. And then put a variable. Okay? And then if you choose variable x, so we need our index is x equal to, let's say, our starting point or the lower limit, and that is 1. So 1, try to substitute for your expression. We have 3 times x, or that is 3 times 1. So it would satisfy ba doon sa first term natin? So hindi. So ano yung pwede mong gawin para makuha natin yung first term natin? So we need to add by 2. Okay? So now, every time na binibigay natin sigma notation mula dito sa series na meron tayo, we have a lot of sigma notation na maaaring maibigay natin. Hindi lang isa. Pwedeng dalawa, higit pa. As long as alam mo yung pagkuha ng expression, ng ating expression, algebraic expressions dyan, or our term, or the summand, mula dun sa sigma notation natin, at it will matter na lang siya doon sa ating lower bound. Okay? Kung saan ka magsisimula. And then, we start with 1. So, 1, 2, 3, 4, 5, 6, 7. So, the upper limit is 7. Okay? So, now, we have now the sigma notation given this expression, and that is the summation of 3x plus 2, okay, from x equals 1 to 7. So that's it. Now, so let's proceed to example number 2. Again, same process. You need to identify yung ating series, kung ito ba ay geometric or arithmetic. So, example number 1 is an example of, this is, okay, so this is an geometric. Okay, so as you can see, we have 1 plus 3 plus 9 plus 27 plus 21 plus 243. So, it multiplied by 3. Okay, so the constant is 3, so it multiplied each term by 3. So, that is also increasing. So, if that's geometric, get the common ratio. Get the common ratio by divide 3, our second term, and then our first term, and that is 1. So that is 3. And then next is we have 9 divide 3. 9 divide 3, see, we have also 3. Then 27 divide 9 is also 3. And then 81 divided 27 is also 3. And then 243 divided 81 is also 3. Now, if we have a common ratio for that geometric series, so to rewrite that in sigma notation, write a sigma notation and then put the 3. So we have 3 now, the common ratio. And then since this is a common ratio and 3, and if you observe this, it is increasing. And this is exponential, right? Exponentially increasing this one, this series that we have. So we can write that as, for example, 1 raised to 0 is 1. And then 3 is to 1, raised to 1, right? And then 3 are yung 9, so we have 3 squared. And then in 27, we have 3 raised to 3. 81, we have 3 raised to 4. And then 3 raised to 5. Okay? So it means to say that if ever in the series that we have is in geometric, to rewrite that in sigma notation, so you get the common ratio. And then put a variable on our exponent to be an exponent. So we have, let's say you choose J. Okay? And then J is your initial here. I index. And then start with 1. Let's say 1. So 3 raised to 1 is not 1. It's 3. So it means to say you need to do something here. 3 raised to J. Anong pwede natin gawin? We can subtract by 1 dun sa exponent. And then let's see kung satisfied ba. So 3 raised to 1 minus 1 is 0 yung ating exponent. And then 3 raised to 0 is 1. Okay, check tayo sa first term. And then next, let's say 2. Dapat 3 ang makuha natin. So 3 raised to 2 minus 1. So we have 3 raised to 1. So that is 3. Okay, satisfied. 3 raised to, this time 3. 3 raised to 3 minus 1. So we have 3 minus 1 is 2. So 3 raised to 2 is 9. Okay, so it satisfies also our series that we have. So it means to say that itong ating term, 3 raised to j minus 1, it satisfies our series. So it means to say this is the correct one of rewriting the sigma notation. Okay, so get the upper limit. So 1, 2, 3, 4, 5, 6. So we have 6. So the summation of 3 raised to j minus 1 from j equals 1 to 6. Okay? The next. Let's try example number 3. So observe again. Is this a geometric or arithmetic? Since they are fraction, meron sa numerator no 1, so tingin na lang sa denominator. So tingin sa denominator ko, ito ba ay naka-geometric or arithmetic? So 4, 8, 16, 32, 64, 128. So, nag-multiply din ito by 2. Okay? Nag-i-increase din. So, ibig sabihin, ito ay geometric. Kung ito ay geometric, ganito lang pag-write ulit. Okay? Maglagay tayo ng summation. And then, so check yung common ratio. 8 divide 4 is 2. 16 divide 8 is 2 also. So, since ito ay naka-fraction, 1 na agad ilalagay mo sa numerator. And then, magkakaroon ka ng 2 kasi ito yung ratio mo. And then, di ba, lagi natin ilalagay may variables. Pag naka-geometric to, kailangan yung variable na i-declare mo ay nasa exponent. So, let's say ito ay x na lang. Okay. So, start natin, kunyari, starting point natin is 1. Tingnan natin kung magsasatisfy tayo. 1 over 2 raised to x. So, palitan natin sa x by 1. So, 1 over 2 raised to 1 is 1 half. So, ibig sabihin this starting point natin is 1. So, this is, let's say, 2. So, 1 over 2 raised to 2 is 4. So, 1/4. So, ibig sabihin, 2 ang starting point natin. Okay, so let's try natin. Pag nag-3 tayo, dapat 1/8. 1 over 2 raised to 3 is 1/8, and so on. So, ibig sabihin, 1 over 2 raised to x ang gagamitin natin. Ang pinaka-starting point natin o lower bound is 2. From 2 to, ano yung upper limit natin? Kung nag-start tayo ng 2 sa 1/4, so ito ay 2, 3, 4, 5, 6, 7. So, we have 7 there. Okay? So, yung upper limit is 7. Okay? Then next, proceed tayo sa number 4 and last number. So, try to observe now. This time naman, if we have alternating sign, so, ang ginagawa lang natin dyan, ganito lang yung paraan na gagawin ninyo. Pag nakaka-encounter ka ng alternating sign naman, automatic na, maglalagay ka ng summation ulit. And then, since ito ay naka-fraction, kung ito ay, maglalagay ka ngayon ng negative 1. Okay? Alternating then, automatic magkakaroon ka ng variable na i-declare mo sa exponent. Let's say, ilagay mo ulit x. And then, kailangan mo minus ng 1. Kasi para ito ay since magkakaroon ng alternating, so kapag nagkaroon ka ng even, positive, di ba? Pag nagkaroon ka ng odd na exponent, ibig sabihin negative. So kailangan ganito yung magiging way natin. And then tingnan mo na lang ngayon yung ating denominator. 4, 8, 12, 16, 20, 24. Arithmetic geometry. This is a arithmetic. So ang common difference is 4. So, ang common difference, ilalagay mo na agad. And then, di ba sabi natin, pag may common difference, may kasama siyang variable. Kung variable mo na ginamit is x, so x ngayon. And then, try natin ngayon, kung mag-start tayo kay 1, then, masasatisfy ba natin yung first condition natin na yung first term is 1/4? So, let's see. Negative 1 raised to 1 minus 1, so that is 0 na. Yung is exponent. So, negative 1 raised to 0 is 1 na. And then, 4 times 1 is 4. So, 1/4 ang sagot natin. So, ibig sabihin, try din natin yung pangalawa. 1 over 8 dapat. So, start tayo, ulit tayo ng 2. Negative 1 raised to 2 minus 1. So, we have 2 minus 1 is 1. So, negative 1 raised to 1 is negative 1 over 4 times 2 is 8. So, negative 1 over 8. Okay, so ibig sabihin, itong expression natin algebraic na ito, it satisfies dito sa series na meron tayo. So, next start tayo kay 1. So, bilang tayo 1, 2, 3, 4, 5, 6. So, yung upper limit is 6. Okay? So, that's it. Yun lang yung ating pagsasolve na, o pag-i-evaluate at pag-re-rewrite ng ating sigma notation. So, kung meron po kayong mga katanungan, kung meron po kayong nais i-suggest or anything, so feel free to comment po. Just message lang po ako. Yun lamang po. God bless po sa ating lahat.